Chapter 4, Section 3, Triangle Congruence by Angle Side Angle and Angle Angle Side. Postulate 4.3 ASA, the angle side angle postulate, states that if two angles and the included side, so the side in between the two angles, of one triangle are congruent to the corresponding two angles and included side of another triangle, then the two triangles are congruent. So in the diagram, we're told that angle BAC is congruent to angle DAC. Well, those are corresponding angles. And angle BCA is congruent to angle DCA. Again, those are corresponding angles. Well, the included side between them would be line segment AC. So we want to somehow prove that these two triangles are congruent by angle side angle. Well, we know that this side is congruent to itself by the reflexive property. So our first statement is just the given statements. Our second statement would be that line segment AC is congruent to itself by the reflexive property of congruency. And now we have angle, we have the side in between them, and we have another angle. So we can state that the triangles are congruent because angle side angle is congruent to angle side angle, meaning if two angles and the included side of one triangle are congruent to the corresponding two angles and included side of another triangle, then the two triangles are congruent. And that would be the end of our proof. Postulate 4.3, angle side postulate. If two angles and a non-included side of one triangle are congruent to the corresponding two angles and non-included side of another triangle, then the two triangles are congruent. So the two angles have to be corresponding and the non-included side has to be corresponding. Well, in this proof, it's telling us that EF and DG are parallel, and angle DEF and angle DGF are congruent. Well, if we were, let's say, to extend these lines and look at it as cut by transversal DF, we could say that EFD and GDF are alternate interior angles, so they would be congruent. So now we have an angle, and a non-included side. So we don't want to talk about this side. We want to either talk about these sides or this side. Well, we don't know anything about this side, but we do know that by the reflexive property, this is congruent to itself. So our first statement is just going to be our given, that line EF is parallel to line DG, and that angle DEF is congruent to angle DGF. And that was given to us. So that gives us an angle. That gives us our first A. Now our second A is because the two lines are parallel. Well, I'm going to skip a few statements and say that angle EFD is congruent to angle FDG, because when two parallel lines are cut by a transversal, congruent alternate interior angles are formed. So that's our second A. And now our last is the side that's non-included. Well, that non-included side, the easiest way to prove it here is that FD is congruent to itself by the reflexive property of congruency, And now we have AAS, angle, angle, side. So we can state that the two triangles are congruent to each other. So triangle EFD is congruent to triangle FDG because angle, angle, side is congruent to angle, angle, side, which means that if two angles and a non-included side are congruent to two corresponding angles and the corresponding side, then two triangles are congruent. And that would be the end of our proof.